diagram shows a circle radius r centimeters and two regular hexagons. Each side of the larger hexagon 𝐴𝐵𝐶𝐷𝐸𝐹 is a tangent to the circle, and each side of the smaller hexagon 𝑃𝑄𝑅𝑆𝑇𝑈 is a chord of the circle. So by considering perimeter, show that 3 is less than pi less than 2 root 3. So we mark the center of the circle. So suppose O is the center. Then this would also be the center of the large and small hexagons, isn't it? So by symmetry, it would be the center of this of the three shapes, the small hexagon, the large hexagon, and the circle. So then what we do is we join OP, and then we join OB, and then we drop a perpendicular from O on AB. So then OX would be the perpendicular. OX is the perpendicular, so I name that point X. So this is the point X. So OX is a perpendicular to AB, and it's also perpendicular to PQ, because you see OX is the radius, and radius is perpendicular to the tangent AB, it is perpendicular to the chord PQ. So that's what I wrote down. So then I also marked this point Y. So OY is perpendicular to the chord, OX is perpendicular to the tangent, and that's, so perpendicular. So OX is also perpendicular to the chord, and it also bisects the chord. So so I don't think we are using that fact that it bisects the chord, but still I thought it would be nice to write it down. So then this explains why I drew these lines on the radiuses. Now they're all equal. You see OP, OQ, and OX. They're all equal to the radius r, not OB, so it's OQ. Okay, they're all equal to the radius of the circle. So and also you would notice that triangle OPQ is equilateral. The hexagon, center of the hexagon, and if you were to join all these vertices, you would get 6 triangles. They're all equilateral, and the angle at the center being around point O is 360 degrees. So each triangle will have 60 degrees. There are 6 triangles, and so that's 60 degrees. So that makes them equilateral. All of them are equal sides. The base angles are also 60 degrees. So that makes them all equilateral triangles, and hence PQ would also be equal to R. Then angle POQ, so this angle is 60 degrees, and therefore YOQ, or this angle, or we could also written XOQ. So this particular angle, this angle would be 30 degrees because OX is the angle bisector. So then if you were to consider this triangle, that is OXB, so then tan 30 degrees would be XB out of OX. So this is the bit that's 30 degree. So tan 30 degrees XB out of OX, because triangle OXB is right angled. So then you put in what tan 30 is, root 3 out of 3. I could also written 1 out of root 3, but then I note this. That will be XB out of R, that gives you XB is root 3 out of 3R. Hence we know what AB is. AB is 2 root 3R. So now we know all all the sides or all the perimeters. We can work out the perimeters. So AB is, we know, 2 root 3 out of 3r. We know PQ is r, and of course we know the circle has a radius r. So I write down the perimeter of the small hexagon would be 6r, of the circle perimeter would be 2 pi r, and then the perimeter of the large hexagon ABCDEF, that would be 6 multiplied by the side AB, which is 2 root 3 out of 3r. And then we know that, or we can see the small hexagon, the perimeter of the small hexagon is less than the perimeter of the circle, is less than the perimeter of the large hexagon, and hence we put in the values. You can write 6r is less than 2 pi r is less than 6 times 2 root 3 out of 3r. So then you have to do some simplification to get the answer. So in the format that we've been asked, so that is, so first of all the r, this gets cancelled out, and then 3 times 2 is 6, and then if we divide throughout by 2, then the 2, 2, 3, so we would be left with 3 less than pi less than 2 root 3, and that's what I did. The next slide, yes. So we simplify it to get 3 less than pi less than 2 root 3, which is in the format that we've been asked to show. So hence that's all done.